So this is number 4A. We're going to talk about a bypass capacitor. So this resistor that's part of this N-channel MOSFET is actually RS, means like built in. It's like the inherent resistance of the source. And so imagine if we're trying to drive a steady output. So it's voltage in, current out, but it's getting changed to a voltage because of this load resistor right here. Anyway, so we might have a fixed current going through here, but there's also going to be noise. And so say we have a fixed 1 amp, if we have a really high frequency noise, it's not going to be, it might average out to 1 amp going through RS here, but at times, it might be 1.01 and other times it might be 0.99 amps. But that plus or minus, that little offset that we have from our average value of 1 amp, that is not DC. That's a high frequency. That's noise. So it's anything AC. But when we put this capacitor in here, this capacitor, remember it's going to look kind of like a low resist. It's going to look like a low impedance for a high frequency wave. And again, noise is high frequency. So we have that DC value that's giving us maybe a fixed 1 amp through here. I know this is not a real value maybe, but say we have, or 1 milliamp coming through here. That's coming from DC, but at times it's 1.1 milliamp and at other times it's 0.99 milliamp. That plus and minus is from the AC. So we put this in here. The AC part that's making us go a little bit above and below 1 milliamp gets shorted essentially to ground, because again, capacitors act like they act like low impedance for for AC signals basically. And so what we're left with is that plus and minus that was taking us away from a 1 milliamp through here. That is going to go to ground, and we're going to be left with just our 1 milliamp through here, which means, because we have a more steady current from drain to source, it means exactly that. We're going to have a more steady current through here, and our load voltage, the voltage across this resistor, is going to be more steady. So I hope that was a good explanation of a bypass capacitor.